processes, and how big does it need to be? But sometimes it can be a little bit surprising when you're first looking at Tableau Server. The performance requirements, and particularly the hardware requirements, but kind of understanding all those processes really helps us understand why we need to think about that so carefully. So if you look within Tableau's documentation, you actually get three distinct types of hardware requirements. So if you're thinking of getting started with Tableau Server and you want to install, perhaps as a proof of concept, or perhaps you're doing a small deployment in your organization, then this is really what you want to consider. Now, Tableau themselves stipulate minimum hardware requirements. So this is a 4-core machine with 16 gigabytes of memory and 15 gigabytes of free disk space. Now, it's interesting if you're deploying to the cloud, so something like Microsoft Azure or Amazon AWS or Google GCP, then a lot of cloud servers are specified rather than using the number of physical processor cores, but actually using the number of vCPUs. So you might see a server which is listed as having 8 vCPUs. Now, when it comes to actually Tableau deployments, if you have 4 physical cores on a machine, that is equivalent to 8 vCPUs. So if you actually see an 8-core cloud machine, it's very possible that that's actually equivalent to a 4 physical cores. So when you're looking at these requirements and you're looking in the cloud, what you don't want to do is actually to translate these numbers 1 for 1. It's generally a 1 for 2, and if you do a 1 for 1, you're likely to find that your server is under specified essentially. It's also worth mentioning that if you do any cloud deployments of Tableau Server, Tableau themselves actually do a lot of work for you, and they recommend the particular instance sizes that you would use for each of the 3 major cloud providers. So if you do use one of those cloud providers, I would recommend that you refer to Tableau's documentation and their specific recommendation about what instance size you should use. Now, again, when we're talking about these minimum hardware requirements, these are the minimum requirements at which below this Tableau will refuse to install on your particular machine. It doesn't by any means mean that Tableau will perform well at this level. It just means that it won't perform at all below this level. I wouldn't recommend using these minimum requirements for anything apart from testing and development purposes. So you might actually find that you have a laptop that actually runs Tableau Server at these specs. And I'll typically use this in some of my free time to test new functionalities or to test some new way or approach of configuring Tableau Server. But you definitely don't want to be using this in a production environment. It's purely for testing only. The next tier that Tableau recommend is what they call their minimum hardware recommendations. So this is the bare minimum that they would actually recommend for a production deployment of Tableau. A single node production deployment of Tableau, I should say. And this is an 8-core machine, again, equivalent to 16 vCPUs with 32 gig of memory and a 50 gigabyte free disk. So this will run Tableau in a production environment. But the final recommendation that Tableau make is what they call the hardware recommendations. So rather than kind of being a minimum that they recommend to run, this is the base, what they call the baseline configuration. So if you're really starting out with Tableau and you want to make sure that you're getting the most of your investment, after all, any software deployment like this is an investment in terms of your time and in terms of licenses. This is the specification that you would really want to go to. I've seen deployments before that have used under specified hardware, and unfortunately, it's one of the primary reasons that you might actually encounter issues with your Tableau Server deployment. I myself, when I was a Tableau customer, used some under-resourced hardware below the recommended specifications, and experienced some issues myself purely because of the hardware that I had access to, and that those issues essentially resolve themselves when I was able to actually to use hardware at the right level of specification. So these are quite important things to think about, and it's a very important thing to get right. Now, obviously, this is only kind of the base that you would deploy. So Tableau also provides some recommendations that you could use to plan a larger deployment. So if perhaps you're beyond getting started, or you think that you're going to have a large number of users, then you can use these initial sizing guidelines to help you plan that. So here are the initial sizing guidelines that Tableau recommend and that we also follow. Now, again, these sizing guidelines are actually featured quite heavily in the Tableau blueprint methodology. So I recommend that you refer back to that at some point if you would like any more detail. So the first sizing guideline that they express is that you have 6 to 8 concurrent explorers per call. So what does that mean? Okay, so you might perhaps have 100 users logged onto your Tableau server, but you only at any given point have 64 of those users accessing the server at one given time. Excuse me, sorry. Only 64 of those accessing at one given time. So those 8 calls will serve those 64 users. So this is really about understanding your user base and about understanding the percentage of your users that will be accessing your server at any given time. Typically, in our experience, we see around 10 to 35% as the kind of the peak concurrency of when you would see the most users accessing your server, but it's going to be different depending on your use case. Perhaps you work in a financial environment where you know that everybody is going to be accessing reports on a Monday morning or at the end of the month, and you know that you're going to be experiencing quite a peak load there. Or perhaps you work in an environment where it's more about managing kind of the day-to-day, and there's less peak load. So those kind of considerations will help you understand the concurrency that you require. Now, you'll notice that we said 6 to 8 concurrent explorers per call. So Tableau Server has 3 license levels of Explorer, Creator, and Viewer, and essentially each of those license levels, not because of the license itself, but because of the kind of usage that we expect from those licenses, actually incurs a different performance penalty. So we say that a creator has a relative workload of 2.4 explorers. This is because that person is going to be more likely authoring dashboards. Any dashboards that they have interacted with, they'll be interacting with in kind of more complex manners. So if we have a large number of creators, we're going to need to account for additional workload. Adversely, a viewer is recommended as having a relative workload of only 0.75 explorers. So if you know that the majority of your users are going to be viewers, so these are people that are only viewing dashboards, perhaps interacting with filters, and they're not using things like Ask Data, they're not using things like the web edit functionality, then these viewers are going to be using less workload, and you can factor that into your sizing guidelines. So once you've calculated how many concurrent users you're going to have, and what the kind of the correction is for the mix of your creators, explorers, and viewers, you can use that to work out how many calls you might need. So you might say, for example, okay, I need 16 calls in my solution, or I need 32 calls in my solution. Now, typically, we wouldn't recommend that you actually have a single server with all of those calls. For larger deployments, it would be impossible to acquire that kind of hardware. And actually, you're going to get better performance if you distribute Tableau Server across multiple nodes. So the official recommendation is that if you have clusters with a total of 40 or less cores, then you need to use 8 core nodes. And if you have clusters with 40 or more cores, sorry, more than 40 cores, then you would use 16 core nodes. And across all these recommendations, whenever you're specifying your nodes or your hardware, you're really going to want to be specifying 8 gigabytes of memory per physical core. So this makes sure that you've got enough memory for the operation of Tableau, but also make sure that you've got enough memory for any processes that might take place in Tableau, like caching or like having a large number of simultaneous user sessions. Ultimately, depending on your licensing model, Tableau may be licensed per core or per named user. So it really makes sense to make sure that you have enough memory per core, so that you're getting the best value out of those cores. And what we really had here were essentially initial sizing guidelines. So these are kind of a good starting point for your deployment. But really, your actual use case is going to be very dependent on how your users are using Tableau Server. So here are some scenarios or some considerations that you might make when you're planning how many or how much hardware to provision. Firstly, how complex your workbook is going to be. So it might be that you have workbooks that are very simple to load and include a very small number of filters. In which case, you might find that 6 to 8 concurrent users estimate doesn't really hold for you, and that you can actually have a lot more concurrent users on your server. You also have the question of, are you using live or extracted data sources? Now, extracted data sources are a great way of improving the performance of your workbooks and your dashboards from the perspective that they will load faster. But that load is actually being carried out by Tableau. If, for example, you're using live data sources and you're actually querying perhaps a Snowflake database or a BigQuery database or Redshift or any other kind of the large cloud data warehouse providers, that query work has really been handled outside of Tableau. So you don't need to factor in Tableau having the processing power to carry out those queries. Another consideration is, are you refreshing your extracts during working hours, or are you doing this during the day? So, for example, you might work in a retailer and you might have a large amount of data to process, but perhaps you process that data between the hours of 4 a.m. and 6 a.m. in the morning, but actually your users are viewing dashboards between 9 a.m. and 5 p.m. So in that case, you don't need to factor in that you'll be doing extract refreshes at the same time as you're doing dashboard views. So you don't need to worry about your extract refreshes affecting your dashboard loading. But perhaps you have an extract that you're having to load every 15 minutes. Internally, we have an extract that we have to refresh every 15 minutes. So that's running during the day, and we actually have to understand that that's going to have an impact on the performance of our server. Finally, the gold standard that you want to really get to here is how to test how many concurrent users your solution can actually handle. So it might be the case that you, as an initial starting point, you install Tableau Server in its recommended configuration. You create the workbooks that you're going to want to surface to your users. You want a way of testing, okay, based on this server hardware, based on these workbooks, how many users can I actually handle? And what we recommend is a tool called TabJolt to test the reality of that. Now, TabJolt is a point-and-click testing tool that you can use to generate a load against Tableau Server. So in a use case, we might say, okay, we've deployed this Tableau Server, we've added some workbooks. We want to see, okay, how is our Tableau Server going to handle this load if 100 concurrent users are going to access the workbooks? So we could configure TabJolt to simulate the work from 100 concurrent users. We could have that workload simulated over half an hour or over an hour. And then we could see what that does to dashboard performance. Does that affect the load times? Does that affect the error rate, etc.? What we can also use TabJolt to is to test different scenarios. So perhaps we say, okay, we're going to test the load of 100 users. We're going to test the load of 200, 300, 400 users, and keep ramping it up until we get to the point where Tableau Server is no longer able to actually serve those requests. That really gives us a good point. So we can say, okay, we know that the server that we have today is going to support 400 users. Perhaps we know that we only actually intend to have 200 users. So therefore, that the hardware requirements are correct for our current use case. Or it might be the case that we realize that we need to add 800 users, so we actually need to support a larger user base. We could prototype a larger deployment with multiple Tableau Server nodes, and we could use TabJolt to test that it's going to going to correctly handle those loads. So it gives a much better way of predicting how your Tableau server deployment is going to perform, rather than actually adding 800 users into the mix and then waiting at the end to find out how it actually handles based on feedback from your users.